Inertia as an emergent pressure gradient from the quantum vacuum, a field of inertia theoretic hypothesis. 1. Introduction. Despite its central role in classical and modern physics, the origin of inertia remains elusive. While the concept is mathematically well-defined within Newtonian mechanics and seamlessly integrated into the formalism of general relativity, its physical mechanism has never been identified. In this work, I propose a field of inertia theoretic model in which inertia arises from the disturbance of an isotropic background field of virtual photons, the electromagnetic component of the quantum vacuum, and is experienced by an accelerating body as a reactive pressure force. 2. Properties of inertia. To attribute inertia to a physical mechanism, we must first isolate its fundamental properties as derived from empirical observation and theoretical necessity. 1. Universality. All physical bodies with mass exhibit inertia, independent of their internal structure or composition. This universality extends beyond macroscopic objects to the subatomic level. Every constituent of matter, notably the fermions such as electrons and quarks, also exhibits inertia. Inertia is thus not an emergent property of composite systems alone, but a fundamental characteristic of all massive fermions particles. 2. Isotropy. Inertia presents no directional bias. Resistance to acceleration is the same in all directions, indicating that any underlying field responsible must be isotropic. 3. Proportionality to mass. The magnitude of inertial resistance scales linearly with the object's mass. 4. Zero threshold. Even an infinitesimally small force causes acceleration, implying that the inertial response is continuous and threshold-free. 5. Immediate reaction. Inertia is non-retarded. Acceleration begins immediately with applied force, suggesting a local and instantaneous interaction. 6. Frame dependence. Inertial effects are clearly defined only in inertial frames. In non-inertial frames, inertial effects manifest as fictitious forces. 7. Momentum conservation. Inertia preserves momentum in the absence of external force, consistent with spatial and temporal symmetries per Noether's theorem. 8. Equivalence to gravitational mass. Empirically, inertial and gravitational mass are indistinguishable, hinting at a common underlying mechanism. These features set constraints on any physical model attempting to account for inertia. 3. Candidate for the physical origins of inertia. Several speculative frameworks attempt to identify a cause for inertia. The Higgs mechanism assigns rest mass to particles but does not account for resistance to changes in motion. Field of inertia hypothesis proposes a physical field from zero-point field or vacuum fluctuations, the quantum electromagnetic vacuum, that resists acceleration via anisotropic pressure from virtual photon interactions. 4. Conceptual model. Inertia as reaction to vacuum pressure. I propose that inertia is a macroscopic manifestation of microscopic field interaction, specifically, the result of an imbalance in the isotropic flux of virtual photons that permeate the vacuum. 4.1. Isotropic virtual photon field. Quantum electrodynamics describes the electromagnetic field as quantized, populated by transient virtual photons that mediate electromagnetic forces even in the absence of real particles. This quantum vacuum is not empty but contains a sea of virtual particles exhibiting stochastic, isotropic fluctuations. In the inertial state, a body is immersed in a symmetric field. No net force arises due to perfect pressure cancellation in all directions. 4.2. Disturbance by acceleration. When a body accelerates, this equilibrium is disturbed. In the direction of acceleration, the body interacts with virtual photons more frequently. In the opposite direction, the relative interaction rate decreases. This breaks the isotropic symmetry, creating a net pressure gradient. The result is a reactive force named inertial force opposing the acceleration. 5. Analogy to fluid dynamics and pressure models. This interpretation of inertia mirrors the behavior of a body in a pressurized medium. A body at rest in an isotropic fluid feels no net force. Acceleration disrupts the equilibrium, creating a wake or gradient. The system resists change, not due to intrinsic mass, but due to environmental resistance. This model explains why inertia manifests only during acceleration, why the force is always r-positional and instantaneous, why it is uniform in all directions. 6. Comparison to known quantum vacuum phenomena. Several quantum vacuum effects support the plausibility of this interpretation. 6.1. Casimir effect. Two uncharged, closely spaced plates in vacuum experience an attractive force due to modified virtual photon modes between and outside the plates. A static pressure imbalance caused by boundary conditions. This proves that the quantum vacuum can exert measurable forces. 6.2. Dynamical Casimir effect. An accelerated mirror in vacuum emits real photons due to modulation of vacuum modes, a dynamic response of the vacuum to motion. 6.3. Unruh effect. An accelerating observer perceives a thermal bath where an inertial observer sees vacuum, implying that acceleration modifies vacuum structure. These effects reinforce the notion that motion can influence vacuum fluctuations in observable ways. 7. Inertia as a vacuum reaction force. Summary of model. Hypothesis. Inertia is the manifestation of a pressure reaction force exerted by the quantum vacuum on the entire volume of a body, in response to acceleration. This pressure originates from virtual photons that fill space isotropically in inertial frames. In the rest or uniform motion state, a body is immersed in the equilibrium of virtual photon interactions. The center body's center of mass receives equal pressure from all directions, resulting in no net force. This equilibrium reflects the isotropy of the vacuum. When a body accelerates, this equilibrium is disrupted. The distribution of virtual photon interactions becomes anisotropic. A pressure differential is created throughout the entire volume of the body. This generates a reaction force experienced as inertia that opposes the acceleration. The interaction is not superficial or limited to an external boundary. It is a volumetric effect, rooted in the fact that every constituent of the body is coupled to the electromagnetic vacuum field. Mathematical expression. This matches Newton's second law in form, but here, the origin of the inertial force is not abstract, it is physically modeled as a pressure gradient integrated over the body's volume, caused by the disturbance of the virtual photon flux of the quantum vacuum. 8. Physical significance and testable implications. Provides a physical causal explanation for inertia. Aligns with quantum field theory without introducing new particles. Predicts potential new effects under extreme acceleration. 9. Conclusion. By interpreting inertia as a pressure gradient effect caused by a disturbance in the isotropic flux of virtual photons, this model integrates classical mechanics with quantum field behavior. It assigns a physical mechanism to a traditionally axiomatic concept, aligning with modern observations such as the Casimir and Unruh effects. This framework offers a new direction for investigating the fundamental nature of mass, motion, and spacetime, one where inertia is no longer a primitive given, but a reaction from the quantum structure of reality itself.